Baseband is a signal that has a very narrow and near-zero frequency range, i.e., a spectral magnitude that is non-zero only for frequencies in the vicinity of the origin, termed f equals 0, and negligible elsewhere. In telecommunications and signal processing, baseband signals are transmitted without modulation. That is, without any shift in the range of frequencies of the signal. Baseband has a low frequency, contained within the bandwidth frequency close to 0 Hz up to a higher cutoff frequency. Baseband can be synonymous with low-pass and non-modulated, and is differentiated from passband, bandpass, carrier-modulated, intermediate frequency, or radio frequency, RF. Various uses. Baseband bandwidth. A baseband bandwidth is equal to the highest frequency of a signal or system, or an upper bound on such frequencies. For example, the upper cutoff frequency of a low-pass filter. By contrast, passband bandwidth is the difference between a highest frequency and a non-zero lowest frequency. Baseband channel. A baseband channel, a low-pass channel, or system, or network, is a communication channel that can transfer frequencies that are very near zero. Examples are serial cables and local area networks, LANs, as opposed to passband channels such as radio frequency channels and passband filtered wires of the analog telephone network. Frequency division multiplexing, FDM, allows an analog telephone wire to carry a baseband telephone call concurrently as one or several carrier-modulated telephone calls. Digital baseband transmission. Digital baseband transmission, also known as line coding, aims at transferring a digital bit stream over baseband channel, typically an unfiltered wire. Contrary to passband transmission, also known as carrier-modulated transmission, passband transmission makes communication possible over a bandpass filtered channel, such as the telephone network local loop or a band-limited wireless channel. Baseband transmission in Ethernet equals the word base in Ethernet physical layer standards. For example, 10BASE5, 100BASETX and 100BASESX implies baseband digital transmission, i.e., that a line code and an unfiltered wire are used. Baseband processor. A baseband processor, also known as BP or BBP, is used to process the down-converted digital signal to retrieve essential data for the wireless digital system. The baseband processing block in receivers is usually responsible for providing observable data, code pseudo-ranges and carrier phase measurements, as well as navigation data. Baseband signal. A baseband signal, a low-pass signal, is a signal that can include frequencies that are very near zero by comparison with its highest frequency. For example, a sound wave form can be considered as a baseband signal, whereas a radio signal or any other modulated signal is not. Equivalent baseband signal. An equivalent baseband signal or equivalent low-pass signal is, in analog and digital modulation methods, for bandpass signals with constant or varying carrier frequency. For example, ASK, PSKQAM, and FSK, a complex-valued representation of the modulated physical signal, the so-called passband signal or RF signal. The equivalent baseband signal is ZT equals IT plus JQT. Display style ZT equals IT plus JQT backslash closing curly bracket, where IT display style IT closing curly bracket is the in-phase signal, QT display style QT closing curly bracket the quadrature phase signal, and JT display style j, the imaginary unit. In a digital modulation method, b, I, t, display style I, t, closing curly bracket, and q, t, display style q, t, closing curly bracket. Signals of each modulation symbol are evident from the constellation diagram. The frequency spectrum of this signal includes negative as well as positive frequencies. The physical passband signal corresponds to I, t, cos, omega, t, minus, q, t, sin, omega, t, equals, r, e, opening curly bracket, z, t, e, j, omega, t, closing curly bracket, display style I, t, cos, omega t, q, t, sin, omega t, equals mathroom, re, z, t, e caret, j, omega t, closing curly bracket, where, omega, display style, omega, is the carrier angular frequency in radian per second. Modulation. A signal at baseband is often used to modulate a higher frequency carrier signal in order that it may be transmitted via radio. Modulation results in shifting the signal up to much higher frequencies, radio frequencies, or RF, than it originally spanned. A key consequence of their usual double sideband amplitude modulation, AM, is that the range of frequencies the signal spans, its spectral bandwidth, is doubled. Thus, the RF bandwidth of a signal, measured from the lowest frequency as opposed to 0 Hz, is twice its baseband bandwidth. Steps may be taken to reduce this effect, such as single sideband modulation. Some transmission schemes such as frequency modulation use even more bandwidth. The figure shows what happens with AM modulation. See also complex envelope, broadband, narrowband, wideband.